In the previous video, this is where we left off. Now, we're going to go through and we're going to derive the equation of this particular hyperbola using the definition. But when I look at my diagram, I can see that D1 is definitely smaller than D2. So to eliminate the absolute value from the equation, I'm going to do D2 minus D1, which is still the difference, but I'm doing the bigger distance minus the smaller distance to get a positive value naturally without using that absolute value. Okay, so we're going to rewrite this to be D2 minus D1 is equal to 14, okay? So we're going to need to use the distance formula twice, but we need to know what points we're going to be using. So we have a generic point that's at some point x comma y. We don't even know its precise coordinate points, but that's okay. We also have the focus point at 0, negative 8, and the other focus point at 0, positive 8. All right, so let's take a look at D2. D2 used the point P, and it used the bottom focus point at 0, negative 8. So this is going to give me the square root of distance formula, difference between the x values, x minus 0 squared, plus difference between the y values, y minus negative 8 turns into plus 8 squared. Okay, so that's D2. Now we've got to look at D1. Well, D1 still used the point xy, but it used the other focus point, the 0, 8. So that is going to give us, we have the subtraction in between, and then we have another square root, and it's going to look very similar. We have x minus the x value of the focus point, squared, plus y minus the y value from the focus point, squared, okay? And that all has to equal 14, all right? So now let's clean this up a little bit. So now we have the square root of x squared plus. Now I'm going to multiply out the binomial squared, the y plus 8 squared, to get y squared plus 16y plus 64. Need a little bit longer there. Okay, there we go. Minus. And now this second square root is going to look almost identical. I'm going to have the x squared again, but now I'm going to have y squared minus 16y plus 64. All right, and this is all equal to 14 still. So now I have an equation to solve that has two square roots in it. And the square roots are both on the same side, which we want to avoid. So what I'm going to do is I'm going to move this square root right here to the other side of the equation by adding it over, okay? So now I have the original square root on the left, x squared plus y squared plus 16y plus 64 is equal to 14 plus this other square root. Now, is this step 100% necessary? No, but it will make life a little bit easier for us. Okay, so now I have a square root equals a number plus another square root. And to get rid of a square root, we need to square both sides. But we have to square sides, not terms. So I'm going to square both sides. Okay, so what is that going to give me? So over here on the left, I'm going to have x squared plus y squared plus 16y plus 64. All right, a square root square just gives me the radicand left-hand side. Now the right-hand side, technically it's a binomial squared, so I'm foiling this out. So this is where I'm going to say a lot of things, but not write every step down. So I would be doing, the short version of this is I'm doing 14 plus a square root times 14 plus a square root. All right, I'm going to leave that there as a frame of reference, but it isn't going to stay there permanently. All right, so first times first, 14 times 14 is 196 plus. And then I've got 14 times the square root plus 14 times the square root. That'll be 28 square roots. So I'm going to write 28 square root. Now the square root's really long and I don't have a ton of space, so I'm going to leave it blank. But this expression is going to end up there in the long run, okay? And then last times last, square root is the inside. So I get x squared plus y squared minus 16y plus 64, okay? And you should now see that there are a lot of like terms between the two sides of this equation. So there's a lot of things that I can just go ahead and cross off now. I've got an x squared and an x squared, a y squared and a y squared, a 64 and a 64. So I've just eliminated a lot of terms, which makes this easier, but this still is not easy. All right, I'm going to add over the 16y and add over the 16y. I'm also going to subtract over the 196 because I want to try to get this square root by itself, all right? I want it isolated so that when I square this again, I won't have to do any additional algebra after the fact because the radical will be completely gone. All right, so here's what we got at this point. I've got 32y minus 196 is equal to 28, and now I'm going to fill in the full square root. Okay, so inside the square root is an x squared plus y squared minus 16y plus 64. All right. Now, there is a common factor of, I believe, 4 here, but I'm not going to divide it out at this point. I'm just going to dive right in, and I'm going to go ahead and I'm going to square both sides again. Oops, wrong color. So I want to square this and square this. Now, this is where you need to just trust me, okay? I multiplied it out. I did it very carefully, and this is what we end up with. 1,024y squared minus 12,544y plus 38,416 equals, all right? 28 squared is 784, and then I've got the inside of the radical. That radicand sticks around, but the radical sign will now be gone. Okay. So again, just trust me on that. I checked the algebra multiple times. This is what we get. Now from here, we would distribute the 784 next, and then we would move things over to kind of get our like terms situated, all right? Now I'm not gonna write out that distribution because as you can see, I'm kind of running out of space here. I'm gonna scroll down a little bit, but this is all the space I have left. So I'm gonna distribute there, but then I'm also going to move terms to the other side. So for example, the 784x squared on the right, I'm gonna subtract it over to the left. All right, this is what we're gonna end up with when we distribute and move things over. I want the x's and y's on the left, and then I want the constants on the right, all right? And when I do that, I'm gonna end up with this. I'm gonna get 240y squared minus 784x squared, and it's going to be equal to 11,760. All right, guys, we're getting close, okay? But again, that's from distributing the 784 with those green lines that I drew, and then also moving variable terms to the left and moving constant terms to the right. That's how I got to this point. You can do it out on your own if you want, but again, this is not a process you're going to be required to do in this particular course. So hopefully this is enough for you guys at this point. Next, final step. Like an ellipse, a hyperbola has to equal 1. So I'm going to divide out the 11,760 from both sides of the equation. So I'm going to do it term by term, all right? And then I need to simplify the individual terms. So here's what we're going to end up with. 240 over 11,760. Well, believe it or not, 240 goes into 11,760 nicely. This comes out to y squared over 49. All right. And then, again, believe it or not, 784 goes into 11,760 nicely. This is x squared over 15. And then we have our equals 1. This is the equation of the hyperbola on the previous slide in the opening video. Okay. Now, again, you're never going to have to use this distance definition again. But what we can see here is now it looks very similar to the format of an ellipse. I've got x squared over a number, y squared over a number equal to 1. The main difference here is this subtraction. And we're going to talk about why that's important later. But here's a quick way to remember it. Hyperbolas are related to the difference between the distances. So there is a difference or subtraction in the equation. Ellipses were about finding the sum of the distances, so there was a sum or addition in the formula, okay? So this is the equation from the definition, and we're going to talk next about the anatomy of a hyperbola and how to create their graphs. See you in the next video.